All right, 3.4. We are now combining transformations. We're going to do more than one thing at a time. So we're going to have some stretching, some reflecting, and some translating all at the same time. Let's first of all get started here. Looking at the graph of the original, the red, how do we get to the blue? What has happened? And we need to get an equation for that. So the first thing you want to do is pick off a point. And they're giving you points that we know. We know that point goes to that point. So it moved there. And then this point moved all the way over to that point there. We need a rule that's going to work for both of those points. Well, first of all, let's talk about stretches. Is the shape the same or is the shape different? The way that you can check that is look at your 2 points. So this point and that point. How long is it between those 2 points vertically and horizontally? So horizontally, it's 1, 2, 3, 4 long. And it's 2 high. So let's look at the new one. Okay, so 1, 2, 3, 4. Oh, it's the exact same length horizontally, so there's no horizontal stretch. No horizontal stretch. But now let's look at the vertical. It was 2 high. It's also 2 high, so that means no vertical stretch. We're only going to have translations involved. So take those points and move them. This point went down 2, 1, 2, and it went left 1, 2, 3. Let's just check with the other point, make sure that's true as well. Down 2 and left 3. Perfect. So we went down 2, left 3. Whenever you're making an equation, I'll always recommend that you use your replacements. Less mistakes get made that way. Then you don't have to worry about what's opposite, what's not opposite. If you're going down 2, every single time, down 2, that's vertical. So that's going to be a y replacement. Into the equation, wherever we see a y, we're going to put, and down, we're going to do opposite. Y plus 2. And left, that's horizontal, so that's an x. And we do the opposite of left, so we're going to go x plus 3. Take the equation, pump those in there. So, starting with our original equation here, okay, and plug in your 2 values. So then y plus 2 equals, and wherever you see an x, we're going to put x plus 3. So the square root was already in there. And then, oh, there's the x, so I put x plus 3 into that x spot. The only last thing that you can do is, if you wanted to, you can leave it like this. This is fine. But in order to use a graphing calculator and those kind of things, we isolate the y again. So you can leave it as y equals square root of x plus 3. I suggest putting brackets. That's inside the brackets with the x. Minus 2 outside of the square root. All right, looking at the next one here. Again, start with one of the points on the original and see where it goes to on the new one. They give you 2 points. 1 point's here and 1 point is there. Horizontally, they're both the same. So from the original red one here to there, it's 1, 2, 3, 4 wide, and it's also 4 wide. So that means no horizontal stretch. Vertical stretch now. Do the same thing. Go to the original red one and to there. It's 1, 2 up to the next one. Now it's only 1 up. So yes, there is a vertical stretch. So we now have a vertical stretch by a factor of. Well, the original was 2 distance. That distance now is cut in half. So it's by a factor of 1/2. Let's look, is there any translations? Well, if there was a translation, that would mean that those points would have been moved left or right or up or down. This point stayed at the same point, and it was on the axes. So there's no way that it could have been translated, because this point just went straight up and down, and that's already taken into account by the vertical stretch. So there's no translations. Let's plug her into the equation. Vertical stretch by a factor of 1/2. I highly recommend using your replacement method here. Less mistakes. As soon as we do that, vertical, so it's y. Stretch, so we're multiplying. And we're multiplying by the opposite, 2y. So wherever you see a y, put 2y. So our new equation is going to be 2y equals the square root of x. But like we just said, hey, let's re-isolate for the y. Resolve for y. And you can leave it like this. This is okay to leave it here. But if we take the 2 over, we get 1/2 root x. You could have just jumped straight to this answer by saying, oh, it's vertical. Put it on the wrong side. Keep it the same number. Done. All right, look at this. We're just building and building and building. Let's start with our original. I'm going to, just looking at what's going to happen here, I'm going to put my axes straight down there, and I'm going to put it way down at the bottom here for the other axes. I suggest you do the same. All right. When we have y equals absolute value of x, it looks exactly like y equals x, which is going straight through, oops, drew it a little bit off at an angle, but it's going straight through all of these as long as I've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and negative 6, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. When we go through, I want to go right through each one of these intersection points. And then coming up on the other side, an absolute value kicks everything up from the negatives. Can't have negatives. So it flips it up so that we're going in the opposite direction. Just like we did with the piecewise functions in 20-1. So there's our original. Y equals the absolute value of x. Now, what happens if we put a 2x there? That says horizontal stretch by a factor of 1/2. So we're going to make it half as big horizontally. Or in other words, multiply all x values by 1/2. We got a whole whack load of x values there. So here's 1/2. There's 1/2. Half. Half. It's now going to be half as big. This one, half. 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 Straight up through there. So there's y equals absolute value of 2x. Let's keep adding to it. Now we're going to throw in front of it. This is the next thing. Starting from that green line, we're going to put a 1/4 in front. And that's a vertical stretch by a factor of 1/4. It's on the wrong side, so we just keep it as the same. I don't have to do the opposite again. Now this says multiply all the y values by 4. So let's do that now. Sorry, I meant 1/4. Multiply all the y values by 1/4. There we go. So, from the green one, we're adding on to it because the 2x is in there. So let's take this point here, which is 1, 2, 3, 4, 5. So 4 multiply it by a quarter, that takes us down to 1. This point here was at 8. Multiplied by a quarter, 2. Do the same thing on the other side. 4 goes down to 1. And that is y equals 1/4 of absolute value of 2x. And just because we're building on this again and again, I'm going to pull off the other ones right now, just to try to clean up our graph, just so you can see it a little bit better. Now what we did, we still have everything the same, but we've replaced x with x plus 3. As soon as we do that, that's a horizontal translation. Horizontal because it's x. Translation because there's adding and subtracting in there. And 3 to the, when we're talking replacements, it's always the opposite. Plus 3, that's going left. So we're going to take this graph that we've just drawn, which is exactly the same shape. It has the same vertical, same horizontal stretches. We're going to take that same shape and move it 3 to the left. Every point we subtract 3. So here's a point, 1, 2, 3. Take this point, 1, 2, 3. This point, 1, 2, 3. This point, 1, 2, 3. So we've got, that is our new one. That blue one there is y equals 1/4 absolute value of 2x plus 3. Oops, there we go. Now we're going to take that graph because everything's the same up to this point. So that's all the same right there as we had right here. The only thing that we are doing different is adding on the end a plus 4. Let's add that plus 4 on there because that says to do a vertical translation for up. It's on the wrong side, so we don't have to do the opposite again. It could have been y minus 4 equals, but we've taken it to the opposite side. So let's do that last thing. Let's take everything up 4, or add 4 to every y value. 1, 2, 3, 4, right there. 1, 2, 3, 4, there. 1, 2, 3, 4. This one was up here. So we get the exact same shape, but moved up 4. Okay, so how do we describe it? We're going to go in order. Stretch before translate. So this is what you want to do. I suggest stretches, then reflections, then translations, even though stretching and reflecting can be done in any order. It tends to be easier to stretch it first and then reflect. So let's say you're deciding, hey, I want to go out and do a little bit of a run. You know, I'm going to go move around, get some exercise, feel a little bit stiff, just sitting doing math all day. So you say, okay, let's go for a run. But wait, before you can go out and run, you don't want to pull anything because then you're like, oh, my hamstring, can't go and do any math. So you say, first thing we got to do, we're going to stretch. And you start doing your stretches. Oh, yeah. Oh, that feels good. Good, there we go. Got it all stretched up. But then you know what? You really aren't going running because you want exercise. I know what you're really going running for. You want to go running past that special someone's house. So you stretched up. You're not going to pull muscle because that would look kind of not so good if you pull muscle while you're running past that person's house. So then you say, hey, I gotta look good. So you look in the mirror, you say, looking good, look at that. You look in your reflection in the mirror. So you stretched, then you looked at your reflection, and now you're gonna go and do your translations and run around and slide the whole graph. So that's the order we want to do it in. Stretch, reflect, translate. Or, hey, you know what? You can make sure your hair looks good first, and then stretch, and then go run around. So you can do R, S, T as well. Either of those two will work out. So let's label them, and let's write them down in that order. So first thing, stretches. I've got a horizontal stretch by a factor of 1/2, followed by a vertical stretch by a factor of 1/4. Then I've got my no reflections happening here, so now I'm into the translations. Horizontal translation, 3 units left, and a vertical translation, 4 units up. That's the description of our transformation language. All right, page 220 there shows you a little bit about order, what I just was talking about there. So, graph of y equals x cubed. We got it going right there. Perfect. So now, first thing we're going to do, translating 2 units down. If we do that first, and then we take a vertical stretch by a factor of 3, we get that green graph. If we do the other one, where we first of all do the vertical stretch, you get that blue line, and then you do a translation of 2 down. And I don't have that graph, but in your book you can see that it comes to here. Let's see that. Which is not the same as the first one. So because of that, we're going to have an order. And I just talked about that order. So make sure you write that down. Stretch, reflect, and translate, or reflect, stretch, translate. Either of them will work. All right, example number 1. I'm going to again change this into just a stretch by a factor of 1/3. So we're doing a stretch, vertical stretch, factor 1/3, translation 2 units up. So vertical stretch by factor of 1/3 means multiply all y by 1/3, and translation 2 up means add 2, 2, and it's going up, so to the y values. All right, let's do the stretch part first. So take every point, we're going to multiply it by 2, so that means how far away from the axis it is, from the x-axis, and then move it 2 up. So let's start with this point here. Multiply it by 2, it's right now at 3, multiplied by 1/3, I don't know why I'm saying 2, multiplied by 1/3, so 3 becomes 1, and then move it 2 up. Hey, it went back to the same place. That's kind of cool. So because it's in the same place, does that make it invariant? No. It moved. It just happened to get back to the same place, but it did actually move, and it got back to there. So invariant points, only ones that don't move at all. So now we got -3 multiplied by 1/3 takes us to 1, -1, and move it 2 up. 1, 1, 2. So it's now here. Next point. 0 multiplied by 1/3 keeps it in the same place, but then we move it 2 up. 1, 2. And we're there. And last point. It's at 6 multiplied by 1/3, whips it way down to 2, and then move it 2 up. 1, 2. And we connect all of our points now. So we've got the sketch, but now we want to label its image. Means, what's the equation? We're starting with y equals g of x. So, the vertical stretch by a factor of 1/3 means we are replacing the y with, when we're doing the replacement, we do the opposite. I'm always going to show the replacement method. You can always jump to the answer yourself. Add 2 to the y. So then that's followed by a y translation 2 up. So that means opposite, minus 2. Do them in that order. So we start with y equals g at x. First of all, we put 3y in. And now we put the second one. Wherever we see a y, put y minus 2. You got to put brackets. We got to substitute. So that's where it's sitting. Everything's on the correct side. Now we're going to start taking everything over to the other side to isolate the y. So y minus 2 equals 1/3 g at x. Add the 2 over. Y equals 1/3 g at x plus 2. There's your final answer. And just label that with your graph, which is y equals 1/3 g at x plus 2. Now, of course, you could have said, hey, I can just jump straight there. Don't have to do any opposites. And I'm okay with that. That's fine. Only works with the vertical because we're on the wrong side. All right, bringing it all together from 3.1 to 3.3. Here's your form. We've got the vertical translation. We've got the vertical stretch. We've got horizontal stretch. And we've got horizontal translation. Those letters K, A, B, and H, those are called parameters. The X and the Y are the variables. Those other letters are the parameters. So, reviewing it all, we can say, all right, if we are taking that y minus k, hey, we can throw it onto the other side. We could then say, get everything equal to y equals a f b bracket x minus h bracket plus k. You're going to have it sitting this way. In order to talk about transformations, the trick here, I'm going to star this. This is the trick. And they love trying to trick you on this one on your diploma. You must have this double bracketed. Or in other words, you've got to factor out your stretch factor. So factor out horizontal stretch so that it's double bracketed. You'll see what I mean as we go along. If we bring all this together, we've got our x value, horizontal. First thing is the stretch by a factor of 1 over b. Hey, x over b. Then we go, the next one, we got minus h in there. We're doing the opposite. If it's horizontal like this, all on the right side, we do the opposite of the b, which is multiplied by 1 over b, and then we add the h on the end. There's our x-coordinate. The y-coordinate, a value, it's on the wrong side, so we can just multiply it by the a. I've got this sitting on the wrong side, just add the k. As long as it's on the wrong side, you don't have to do the opposite. And so now, I talked to you about the order that we do our transformations. Is that what we just talked about? How does that talk about your order? Figure that one out. Alrighty. Number 2. What is this telling us to do? First thing, deal with your stretches first. So this is inside the brackets with the x. All of this is horizontal. So we've got a horizontal stretch by a factor of opposite 2. First thing before you even start here, make sure that this is double bracketed. It is. We're good. We can keep going. So that's our first thing. Horizontal stretch by factor of 2. In other words, that means in English, multiply all x by 2. Next thing, we're going to do our translations. And it doesn't matter which translation you do first. I'm just going to do my horizontal because I'm talking about it right now. So horizontal translation, and that's 1 unit opposite direction to the negatives, left. And finally, we've got this y plus 4. Hey, that's on the correct side where it's supposed to be. So this is a vertical translation, 4 units. And because it's where it's supposed to be, we do the opposite. That is down. The vertical translation means subtract 4 from the y value, and the horizontal translation, because it's going left, subtract 1 from x. We got to do it in the order of the stretches before the translations. Okay, here we go. Let's take each point. They give us 1, 2, 3, 4 points to do. Take this first point, and we're going to multiply all the x's by 2. It goes from 1 to 2, and then move it, subtract 1 back to where it was, and subtract 4. 1, 2, 3, 4. And we've got that one right there. Let's do the next point. Same thing. It's at 2. Multiply the x by 2 takes me to 4. Subtract 1 on the x takes me back to 3. Then go down 4. 1, 2, 3, 4. And we're right in the middle between them. Let's talk about our asymptotes. We've got an asymptote, I'll put it in red, that went through there and there. We're going to do the exact same thing. Multiply the vertical asymptote by 2. It's at 0, so it stays there. But now I move it left 1 and down. Well, it's a line. Moving it down just shifts the line down. So all we're getting to do with this one is moving our asymptote 1 to the left. Let's do our horizontal asymptote. The only thing that's going to affect it is our vertical. And we take it down 4. So 1, 2, 3, 4. Instead of being at y equals 0, our asymptote is now at y equals negative 4. It went down 4 as well. So, connecting our dots, we've got right through here. This y-intercept was actually made from the point that was at 0.5, which was multiplied by 2. From 0.5 went to 1, and then 1 left, and 4 down. That's actually how I got it. Then let's take the other points. We got this point right here. Multiply it by 2. It was at -1. So now it becomes -2. 1 to the left, it's at -3, and 4 down. 1, 2, 3, 4. We're going to put it right there. Take the next one. -2 and -0.5. Multiply it by 2 gets me to 4, -4. 1 to the left, and 4 down. 1, 2, 3, 4. And it's right in the middle of those ones. Same thing. Connect our dots, looking at our asymptotes. Now we've got it drawn. And domain and range. The original domain and range was anything except the asymptote. So this is a fancy way of saying, hey, figure out where the asymptotes are. So our original was just the domain was x cannot equal 0. Your range was also y cannot equal 0, but it could have been anything else. So also xer on the end and yer on the end. Now our new one. Where did the asymptote move to? So in our domain, the asymptote on the x, the vertical asymptote, moved to the left 1. So we're going to take our domain to the left 1. X cannot equal -1, xer. Then our range, we took it down 4. So I'm going to take my range down 4. That's the way that they like to ask asymptote work. All right, your order stuff. See if you can get this answer, which is applied last. Go to that and vote it up. All right, number 3. Whoa, wait a minute. Whoa. Some of you missed this right here. Let me highlight it. There's the link. Go back. Do your Bitly link. Sign into your Google. Okay, I'll wait for you to get it done. Pause it now. All right. Y equals the square root of x. Graph that. And then what's the domain and range? Ooh, they're being tricky here. Look carefully. What do we notice? It's not double bracketed. Okay, so we got to double bracket that. So first thing, before we can even start any of this work, we've got to take it and factor out. Double bracketed. The square root itself really is like a fancy set of brackets. Factor out that 3, leaves me with x plus 1. Now it's double bracketed. Now I can talk about transformations. Up to that point, we don't start touching transformations until I've got a double bracket. Okay, so stretches first. So first thing, the 3. So we've got a horizontal stretch by a factor of 1/3, the opposite. I don't have any vertical stretch, but I do have a reflection now. So I've got a reflection. Keep everything color coordinated for you. And that's a reflection about it's not in the brackets with the x, so it is a vertical, it is talking about the y, and it's always the opposite axis, reflection about x-axis. Next thing, doesn't matter which translation we do, I'm just going to do horizontal first, or sorry, vertical first, because I see it there first. So we've got a vertical translation, and that's 2 units. And direction, it's either up or down. It's where it's supposed to be, so it is going opposite up. And final one, at +1. This is the one that people are going to get wrong if they don't double bracket. Horizontal translation, and that's 1 unit. It's where it's supposed to be, so opposite to the left. take it into English for yourself. The first one says multiply x by 1/3. The second one says multiply y by -1. The third one says add 2 to the y. And the fourth one says subtract 1 from x. Take every point and do that. Okay, so take the point 0 and 0, multiply the x by 1/3, still 0 and 0, multiply the y by -1, still 0, 0, and 2 up, 1 left. So 2 up, 1 left. Plop it right there. Let's take another point. Let's try this point. It's 4 and 2. Multiply. Oh, yeah, that'll work. So, multiply the x by 1/3. Well, that gives me 1.3. And then, oh, I gotta go back here. I forgot to do the reflection. So let's read. Oh no, that one was okay. Sorry. That one was fine. It's this one I gotta do the reflection on. So it goes to 1/3. Then flip it over the x-axis, whips it down to here, and then 2 up, and 1 left. Right there. Okay, so doing that point again here, so the 4, then we get multiplied by 1/3 on the x, takes us to like 1.3, then we go multiplied by -1, so that means it's going to flip all the way down to here, and then we're going up to 1, 2, we're on the x-axis, and 1 to the right puts us at 0.3, so 1/3, just a bit off of there. And now we've got the other easy point, the 9, 3. So 9, 3 is the point we're going to look at now. And we are going, 9, 3, and we're going to take it and multiply by 1/3, takes us to 3, 3 after the first one. And then multiplying the y by -1, 3, -3. Then we add 2, so we're going to take it 2 up from there. 3, -1. And then moving it 1 to the left, which gives us 2, -1. So 1, 2, and -1 right here. And we get it looking like that. Original domain was x is greater than or equal to 0, y is greater than or equal to 0. Now, we've got our new point that we start at right down over there. Oops, I just noticed a mistake here. That shouldn't have been drawn there. Sorry, that should have been drawn like that. That's where our original point, this original point went to there. Sorry. So we are starting from our domain now is everything from this point, which is -1, and to the right. Oops, that should have been a little bit more in there. -1. So for our new domain, we've got x is now greater than or equal to -1. And our range is everything below that point, which was 2. Y is less than or equal to 2. All right, tricky one now here. We're going from the red to the blue. And we need to see what transformations were done. Well, first of all, we need to see what is the relationship between max and mins. That's your easiest place to look at. Let's look at our horizontal stretch first of all. The distance between the two minimums there is 4. So that's 4 in between there. Let's look at the distance between the two new minimums. And that is also 4. So that means there's no horizontal stretch. Let's do the same thing with the vertical. Originally, from the max to the min, there was, so there's 8 on the bottom and 8 on the top. So that means between the two of them originally is 16. On the new one, between the two max and the min, is only 8 now. So we had 16 vertically, now it's 8. That means we must have had a vertical stretch by a factor of 1/2. We're half the height. So let's take a point. I'm going to use point A. If I took point A, half of the distance to the x-axis, that point is 8 above, half of the distance would only be at 4. So we would actually be moving that point down to here after that vertical stretch. Now I've got to get it from that point to where A prime is. That's our translation. I've got to go 4 down, 1, 2, 3, 4, and I've got to go to the left 2, 1, 2. So it means we've got a vertical translation of 4 down, and we've got a horizontal translation of 2 left. And you can go through and you can test the other points. You could do it with B if you would like as well, and you'll get the exact same results. So, vertical stretch, that means y is replaced with 2y. Vertical translation, y is replaced with y plus 4. Horizontal translation, x is replaced with x plus 2. Throw them into your equation, and you got it done. So we're starting with the f of x. So y equals f of x. First of all, do your stretch. 2y equals f of x. Then substitute with brackets, y plus 4 equals f of x. And then last step, 2 bracket, y plus 4 equals f of x plus 2. And last thing, a lot of times they'll do is just resolve for y. So then, y plus 4 equals 1/2 f of x plus 2. And it's okay to leave it there. You'll see a lot of them with the vertical translation still over there. Or take the 4 over, y equals 1/2 f of x plus 2 minus 4. Really, either of these last two are good to leave it at. Okay, and in example 4, if we go back to their original, just looking at the asymptotes in there, answer that question for yourself, as well as discuss the ideas. See if you understand what's going on.